All right, so 15 was another typo. We talked about it in class, so it should have gotten fixed before you tried it. So for this one, we're going to hope that it works out nicely now that I've fixed it. We'll see. But this is a trig sub question. I'm contemplating whether I could do like a clever U sub for it. I think I might be able to. No, because of the three halves. Or can I? I'm going to try it first. I know it's not what you want, but it's what I'm going to do. U is equal to t squared minus 4. Du is then equal to 2t dt. Okay, and so t squared is equal to u plus 4. I'm thinking that just because we get nice here that I can break up this t squared, the t cubed into a t squared and a t. I feel like I can use sub this thing. So let's just go ahead and see what happens. You know me. Always willing to try out something for funsies. All right, so let's just see. We have our t squared is now u plus 4. So this is now t squared, and I'll throw the t over here with the dt. Then I can deal with the du. That's fine. That's not a problem. This would be, let's divide out the 2 on both sides so that's more obvious. We'll have a 1/2 du. Right? That whole point is that now, look, this all went to my du. Cute. Very cute. And then we have the final coup de grace, which is that this u needs to be to the 3/2. But look, we've moved the problem. The gross fractional exponent is now on a u. This could get distributed. Sick. So we 1/2 u to the 3/2. Oops, not 3/2. It's 5/2, right? Plus 4 u to the 3/2 du. So this is equal to 1/2 u to the 7/2 times 2/7. Plus, that'll get distributed. That's a 2 u to the 5/2 times 2/5 plus c. So we'll have a 1/, I did the over and the 7 in a single swoop. 1/7, come on, erase. U, which is t squared minus 4 to the 7/2, plus 4/5 t squared minus 4 to the 5/2 plus c. Boom, done. All right, that was not my goal, right? My goal when I wrote this problem, we're going to go ahead and do trig sub like it was sort of set up for. And I don't think any student did this U sub. It's just not an obvious one in my opinion. So let's think. We have a number we have a variable squared minus a number squared. We need our t squared to equal 4 secant squared theta. So our t has to be, just 2 secant theta. Which means dt is equal to 2 secant theta tan theta. I'm kind of hoping for something nice and magical here where our final answer just has secants in it because we didn't have any weird, well, not secants. I don't know. We'll see. I'm very curious where this is going to go now that I've done it the other way. So let's rewrite this. We know that cubed would be 8 secant cubed theta. We know that entire radical, right? In fact, t squared plus 4. God. T squared plus 4 minus 4. I can't even speak. This would be equal to 2 tan theta. And so if we're raising this to the 3/2, oh, that was if I already took the square root. Look at, I'm being wild. That's 1/2 of that. That's the square root. So if I'm raising that to the 3rd power, I need a 3rd on all of this. Okay, I'm good. I should do a better job of explaining that. So anyways, let me do a better job. We know t squared minus 4 is equal to 4 tangent squared theta. We could work through the rigmarole of substituting, factoring, using that Pythagorean identity, but we should be there. Then we're going to apply a 3/2 to that, the thing I was missing from my original problem. So if we do that, the half and the square are going to cancel. We still have to square root the 4. This is going to equal 8 tan cubed theta. So I'm going to go ahead and replace this. 8 tan cubed theta. And oh my god, I still have to fit all that green crap in there. Holy hell, let me just rewrite this all. So we have 8 secant cubed theta. We have 8 tan cubed theta. And then we have a 2 secant theta tan theta d theta. Disgusting. So we bring all that out. We have a 64, 128. Oh! Secant to the 4th theta tan theta 4th theta d theta. I see I can pull off a single instance of secant squared. So that, I'll do it. I don't want to, but I'll do it. Secant squared theta tan 4th theta. Secant squared theta d theta. The whole goal of this, right, is to find my du. Recognize I can rewrite secant squared theta as what? Tangent squared theta plus 1. Go ahead and rewrite that in red. Come on. So this will be tan squared theta plus 1. All right, so if I want to do a u sub now, I'm not going to write out my u and all that, but I have a 128. I have a u squared plus 1, a u to the 4th, and I have my du because the secant squared is the derivative of tangent. So this is 128, u to the 6th plus u to the 4th, du, antiderivative, we end up with u to the 7th over 7 plus u to the 5th over 5 plus c. We're seeing some similarities already on the two sides, right? We're seeing those 7s and 5s that were in our answer when I did my u sub. I have to go back to my original substitution. So this is 128 tangent to the 7th of theta over 7 plus tangent to the 5th of theta over 5. And then I need to go back to my triangle. Oh my god. And my guess is my triangle is going to end up with you're right, we're going to end up with that square root of that t squared minus 4, which is why we're going to end up with this 2 and that piece. And then there's going to be a whole lot of canceling because we already know from our secant that our hypotenuse over our adjacent is going to be that 2. So we're going to have a 7th power of 2, and that's going to cancel with the 128. It is going to end up the exact same place. This is going to end up with 1 over 7. I'm not going to write my thing. T squared minus 4 to the 7 halves. This one will only have 5 instances of 2. So we'll end up with 2 squared still in the numerator. So we'll have 4/5, and then we'll have our t squared minus 4 to the 5 halves. So this is what you should have gotten if you did the trig sub instead of the wild thing I just decided to try when I saw the problem.